Hi, it's time for another math easy solution. Turn discuss further into the applied project, how fast does a tank drain video series, and now go over part B of question 4. In my earlier videos I went over questions 1, 2, and 3 as well as question 4 introduction to it and part A of it. So make sure to watch those in the video links below in the description because I'm not going to go over a recap of this applied project, but instead I'm going to jump straight into part B of question 4. So here's question 4, and then part B states basically how long will it take for the water to drain completely. And again, this is a continuation of part A, which says suppose the tank has the shape of a sphere with a radius 2 meters and is initially half full of water. Yeah, so it's half full initially. So what this means is the water level in this spherical tank at time is equal to 0 is equal to 2 meters. And then it says if the radius of the circular hole is 1 centimeter and we take gravity is 10 meters per second squared, show that the height satisfies this differential equation. And again, I went over in my last video, so make sure to watch that. So we already have this differential equation, 4h minus h squared dh over dt equals to negative 0.0001 times square root 20 h. And again, so the initial condition is the height of the water at time is 0 is equal to 2 meters. So let's look at part B, and what we're asked to find is how long it will take for the water to drain completely. So we want time t such that, so we want the time t such that the height of the water at this time t is equal to, 0. So we're 0 meters. In other words, it's completely drained out. So what we have to do is, first solve for, the height. So we need to solve for the height as a function of time of the water as it drains from the spherical water tank. And then what we have is 4h minus h squared. This is our differential equation that has derivative of the derivative of the height as well as the height in the formula. This equals to negative 0.001 square root 20h, and we also know, I'll put a colon like that. So, and we also know that the height h of 0 is equal to 2 meters. So that's our initial condition. And again, this is just basically solving an initial value problem where the initial value is 2 meters, and this is what we're asked to solve, is this differential equation. And again, this is a separable equation. So as I showed in my earlier videos on separable equations, again, you can see those in the video link below. We could just separate these to get all the h's on the left side and all the t's on the right side there. But before we get to that, I'm going to write something like this. I'm going to write 4h minus h squared dh over dt. I'm going to just simplify this right side just a tiny bit. So this equals to negative 0.001, and then this is I'm going to write this as square root 20 times it by square root h. So I'm going to just take that square root, which is the same thing as writing here h to the power of 1/2. It's the same thing as square root, and the reason I'm doing that is just easier to divide all this out. So I'm going to divide both sides by h to the power of 1/2 or h squared, so that we can get rid of this over here and move it over here, and then move the dt on this side, just times both sides by dt. Yes, so now what we end up getting, I'll just divide this out, or I'll write 4h, it's basically 4h over h 1/2 minus h to the power of 2 divided by h 1/2, then we have a dh, and then dt is on the other side, so this equals to negative 0.0001. This h power 1/2's cancel. Negative 20, square root 20 times it by now dt. Now we can simplify this by dividing this out. Again, this is just a division of powers. If you want to learn more about this, make sure to watch my earlier video on powers and their properties. So I'll divide this h power of 1 divided by h power of 1/2 as, let's write this a bit neater. Okay, so it's a bit neater h. So this is the same thing as writing, whenever you're dividing powers, you actually subtract powers with the same base. So you can subtract the powers. This is going to be, I'll write this as 2 over 2 to have a common denominator of 2. Again, 2 over 2 is the same thing as 1 minus 1/2. This equals 2. well, that's just h to the power of 1/2. So 2 over 2 to minus 1 over 2 is just 1 over 2. So that's this one. And then the second part here, h power of 2 divided by h 1/2. This equals 2. Same thing, we're going to have h power of 4 over 2 to get a common denominator. So 4 over 2 is just 2. And then common denominator of 2. So minus 1/2, this just equals 2. 4 minus 1 is 3. So 3 over 2. So that's what we have, and we could throw that inside this formula there. I'll just put a line here. Let's throw this inside. So we have 4, and then we have h 1/2 minus h 3 over 2, and then this is all multiplied by dh. I'll move this a bit more like that because we're going to have to put an integral there. This equals to, on the right side, 0.001 square root 20 times by dt. So now that we have t's on one side and then h is on the other side, and it's a bit more simplified, we can take the integral on both sides to just try to solve for the height as a function of time. So that's what we have here. And now that integral of 4h 1/2, well, that's just going to be, you add a power to it, so add 2 over 2 is 3 over 2. And then we divide by that number here, so we'll have a 2 over 3. So and then add the 4 there, because it's a 4 constant there. And then minus, same thing here, add a power, add 1 to this power, which is the same thing as adding 2 over 2, so that's 5 over 2. Then divide by this power, so which is 2 over 5. So we just flip it. So, and then we add a constant 1 for the constant of integration, because we're going to have it on both sides, so we'll write 1 there. An integral of these are all just constants, so we just get 0.0001 square root 20, then dt, this becomes t. Then we add a constant c2. So what we end up getting here is, and then just multiply this, so we have 8 over 3 h 3 over 2 minus 2 over 5 h 5 over 2, and then I'm going to move the constant on the right side and then combine them because it's just a constant. So we have equals negative 0.001 square root 20 t, and this equals to plus c, where the c is just equal to, well, c2 minus c1. I just move it over. And again, subtraction of constants is still a constant. So that's what we have. And this, we're just going to stop here instead of solving it explicitly for h of t. It's not too straightforward to solve it. I'm not even sure if you can solve it explicitly, but we're going to stick with this. This is an implicit solution of h of t. So it implicitly implies that we have basically this is the equation that governs the solution for h of t. So it's an implicit solution for it. And just because it's implicit doesn't mean we can't solve for the height. And now we can still solve for specific values for the height. So first thing we're going to do is solve for this constant c by imposing our initial value, which was h of 0, or the height is half full, which the radius was 2 meters, so h of 0 is equal to 2. So let's plug that in. What we end up having is well, the heights are all 2 now, so 8 over 3 times by 2 to the power of 3 over 2 minus 2 over 5 times h is 2. Put a bracket like that. And then this is 5 over 2. And then this equals 2. Well, negative all this blah 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 times by t, which is 0. It just goes to 0. And then plus c. And now you could plug this in a calculator and then solve for c. But I'm actually going to just go over some algebra and solve this exactly in terms of basically an exact notation of it. Exact algebraic notation, as opposed to just putting in a calculator. And it's just, yeah, it's pretty interesting. And it's a good exercise in algebra. So let's go about doing that. So first thing we'll do is look at this 2 to the power of 3 over 2 and then look at this 2 to the power of 5 over 2. The common thing between them is this 1/2 power, so that's 2. So what I'm going to do is separate them both into having this power of 1/2. So again, using a properties of power functions, we could just go 2 over 3 over 2. Same thing as writing 2 over 2 plus 1 over 2. And then whenever you add, what you can do is now equals 2, it's a multiplication. So 2 power of 2 over 2 is just the power of 1, times it by 2 to the power of 1/2, which is equal to 2 square root 2. So what I'm trying to do is just get a common factor of square root 2, because we have them in both cases. So that's what this 2 to the power of 3 over 2 equals. And now the second part, we have 2 to the power of 5 over 2. This equals to, again, 2 to the power of 4 over 2 plus 1 over 2. That's just 5. So we just separate it like this so that we can get rid of this 1/2. And then what we end up having now is 2 to 4 over 2 is just 2 to the power of 2. So 2 to the power of 2 times 2 to the power of 1. And 1 over 2, this just equals to, well, 4 square root 2. So that's what we have. Let's just plug these inside. So we have C is equal to, I'll just move C on the left side, is equal to 8 over 3, and then this 2 to the power of 3 over 2 becomes 2 times square root 2. And then we have a subtraction, 2 over 5, and 2 to the power of 5 over 2 is 4 square root 2. So let's multiply these out. This will equal 2, and then also I'm going to factor out the square root 2. So we have 2's, take it out of there. We have now 8 times 2 is 16 over 3 minus, and then we have 2 times 4, which is 8 over 5, like that. And again, yeah, you could, let's just simplify this even further because my calculus book has it. Let's go even more algebra, and then look at this 16 over 3 minus 8 over 5. I'm going to multiply, there's no common denominator, but we can create one by just multiplying it top and bottom by 3 over 3 on this side, and then 5 over 5 on this side, so we have a common denominator of, well, these factors times itself, or the denominator is multiplied by itself, so 3 times 5, which is 15. So what we end up having is 16 times 5 minus 8 times 3 is 24, and then the common denominator of 3 times 5, which is 15. And then here, what we could do is, let's just multiply this out. First, the 16 minus 5, what does this equal to? This equals to, well, 5 times 6 is 30, so put the 0, carry the 3. 5 times 1 is 5, plus 3 is 8. So we have this, and then put this 80 here and subtract by 24. This is just, well, 10. This is 7 minus 1. And again, you can learn more about multiplication and subtraction and addition in my early videos, multiplication by hand. Yeah, if you recap on how to do this, watch my early videos on multiplication by hand, etc. So 10 minus 4 is 6, 7 minus 2 is 5. So we have 56. So that's what this top part is equal to. So this equals to 56, which is 16 times 5 minus 24, and this equals to, yeah, 56 over 15. So what we finally end up getting is C is equal to 56 over 15 times it by square root 2. So yeah, this is the exact value of the constant C, as opposed to just putting the calculator. And yeah, it's more fun just doing this algebra by hand. So now we have to find, now that we know C, we need to find what the time is when this completely drains out. So right at h of t is equal to 0. Yeah, so we basically, when the height is 0 meters, what we end up getting is, let's look at this side. So when we plug in 0, this just becomes 0 minus 0 is equal to this whole right side. So what we get is 0 minus 0, it's whatever, 0 power of whatever, minus divided by whatever is all 0. This equals to negative 0.0001 square root 20 times t, because we have to find what t is when it's fully drained, plus the constant c, which is, well, this number right there, which is 56 over 15 square root 2. And again, this is our C. That's our C value. Yeah, so now let's just solve for t. So what we'll do is move the t on the other side. So we'll have this, just to make it positive, and also this 0.0001. This is the same thing as writing, I'll just write this out, 0.001. This is just the same thing as writing 1 over 10,000. Because the number of decimal places is equal to the number of zeros here, so 1, 2, 3, 4, etc. And that's why there's 10 zeros. So that's what this equals to. So when we move it over, we get, basically, we're going to have this square root 20 over 10,000 times by t is equal to 56. 15 square root 2. So now we'll just remove this, or multiply both sides by 10,000, move it over this side, and the make it on top, and then the square root 20, move it at the bottom, multiply both sides. So we get rid of the t, solve for it, we get now 56 times 10,000, that's just, well, 56, 560,000. So just 4 zeros there, divided by 15, and then we have the square root 2 over square root 20. And again, you could plug this in a calculator to get an answer, but again, I want to solve this exactly and also work on my algebra. Let's look at the square root 2 over square root 20, just to try to get an exact answer. This is the same thing as writing square root 2 over 20, because it's the same power. And this is equals to square root, just divide this out, 1 over 10, which equals to 1 over square root 10. But my calculus book doesn't like having square roots at the bottom, so the way it does it, it just multiplies top and bottom by square root 10, so that the bottom just becomes 10. So this just equals to square root 10 over 10. So it doesn't like square roots at the bottom. Square root 10 times square root 10, square roots just cancel, or it just adds up to 1, so we have 10 at the bottom. So what we end up finally getting is 56000 divided by 15, and then this is a square root 2 over square root 20 is just going to be square root 10 over 10. So let's just cancel, this 10 cancels, removes a 0 here, and what I'm also going to do is, right, so this is going to be 56,000 now, and I'm going to write here, because this is a 15, it's a factor of 5, I'm going to write this as 5 times 3, or is what my calculus book does. Again, there's a square root 10, and the reason is because there's a 0 at the end of this last digit. That means you can divide it out by 5 cleanly, because 5 is just going to be, 5, 10, 15, 20. It's always a 0 or a 5 at the end. So what we get now, let's just divide that out by hand to see what we get. Again, if you want to learn more about division by hand, watch my earlier video on that in the description below. So yeah, you can plug this all in the calculator and do that yourself quickly, but where's the fun in that? So let's look at this divided by 5, write it out like this. 5 goes into 5 once, and then multiply by 5, and then we subtract. Then 5 minus 5 is 0. Put this, carry the 6, so 6. 5 goes into 6 once. 1 times 5 is 5. Subtract it, we get a 1. Carry the 0, so now we have 10. So 5 goes into 10 twice. And then 2 times 5 is 10, and then this is going to be, well, 0, carry the 0, and then 0, 5 goes into 0 0 times, carry the 0, 5 goes into 0 0 times. So that's what our answer is. And then what we get is basically what this says is 56,000 divided by 5 is equal to 11200. And again, you can't divide 3 out into it. Yeah, you can't divide out cleanly, because there's no real factor of 3 here. You could even double check that. And you could double check it by, well, let's just divide this 1120 by 3. So we get 3, 11200. 3 goes into 11 3 times, and then 3 times 3 is 9. Minus this, we get 11 minus 9 is 2. Carry the 2, 22, now 3 goes into it 7 times, which is 21, 3 times 7. And then subtract, we get a 1, and the 0 goes here, this goes into 3 times, to get a 9, subtract, we get a 1, etc. We get a 0 again, and then do the same thing over and over again. You're just going to get, well, 0, carry the 0, and it's always going to be 3. It's always going to be a 3 times 3 is negative 9 here, so 1, and carry the 0, you'll get a 10, etc. It keeps going on and on. We keep getting, well, 0, 0, this can be 3, 3, etc. Put a line above meaning infinite. So it doesn't cleanly divide it out, so we'll just leave it out. Again, that's just for completeness sake. So having this all together, now we get finally t is equal to 11200 divided by 3 times square root 10. This is the exact answer. And this is in seconds. I'll write seconds. So that is our answer. Yeah, but that answer, again, that's not it's not what engineers or whoever wants a practical answer wants to find. So instead, let's put in a calculator, and we get this. So 11,200 times square root 10 divided by 3 is equal to 11,805. So 11,805.833, etc. Since these are in seconds, let's just round it up to 0 decimal places. So we get, this is roughly equal to 11,806. Let me just check that again. 11,800 and then 5.8. Let's round it up to 6. So around 11,806 seconds. Yeah, so this is in seconds, but again, seconds isn't that practical. So let's first convert this into minutes. And you could just, I'll do this by hand. I'll circle the seconds out. It's pretty interesting. And then so times this by minutes. 1 minute over 60 seconds. That's the conversion, like that. And again, let's stick to the dividing by hand because I don't want any decimal places here. So what we get is 60 over. Again, you can put in a calculator and do whatever. I just want to do this for algebra's sake, and also it's pretty interesting going over different unit conversions. So 60 over dividing 60 into 11,806, what we get is, well, 60 goes into 118 one time because number 60 times 2 is 120. So this is going to be 1 times 60 is like that. 60 plus 60 is 120. So here this is 2 minus this is 2 less than 120. So that's just 58. So the difference is 58. Carry the 0 here. Remember, 60 times 10 is 600. So the next closest is a 9. So this goes into 9 times. So 9 times 6 is 54. So 540. And then the difference here is 40. And then carry the 6 here. So we have that. And then 60, well, the next closest here, 6 times 6 is actually 36. So I'll put a 6 here because it's 60. So 6 times 60 is 36, 0. And then subtract here, we get a 6. Carry this as a subtraction, put a 10. And then minus here is a 3. So we have 10, this is 46. So we have a remainder of 46. That's why I didn't put in a calculator. So what we get here is 196 plus 46 over 60, and then the units are on this are minutes, which is, well, the same thing as writing, well, this is 46 over 60, that's 46 seconds. So what this means is t is roughly equal to, and I'll write 196 minutes plus 46 seconds. So I'll write sec like that. So this is what we have so far. That's another way of writing it, but let's just write this in hours, so we can write this 196 into hours. And again, so 196 minutes times it by 1 hour over 60 minutes. Again, a conversion again. This one we don't need to do the long division. You could easily see that, well, 6 goes into 19, well, 3 times. This is the same thing as writing, well, and then, yeah, 3 times 60 is 180. So we have 180 plus, and the difference 180 and 196 is just 16. So 180 over, so what we get over here is 60. And this is all in units of hours. This is in hours because the minutes cancel. So again, 60 goes into 180. I just divide that up. This is 3 hours, so we get a 3 plus a 16 over 60, and this is in hours. And again, this is the same thing as writing, well, the 16 over 60, that's, if that's an hour is a fraction of an hour, which is, well, what 16 minutes are. So this equals 3 hours plus 16 minutes. So, and then putting this inside, we get, finally, t is roughly equal to 3 hours. So after 3 hours and 16 minutes, and, or I'll just write a plus instead. So plus 16, so plus 16 minutes, and then plus finally 46 seconds. I'll highlight this. So this is how long it takes to drain, and then what my calculus book does is just rounds it up to 17 minutes, or in other words, 3 hours and 17 minutes. And it's all roughly because we rounded up initially. So that's what our answers is. So after just over 3 hours is how long it takes for that spherical tank to completely drain of water when it was initially half full. Anyways, hopefully you learned from this pretty intense algebra and calculations by hand video. Again, it could be quicker if you just put in a calculator, but where's the fun in that? Anyways, hopefully you'll learn from this pretty interesting applied project. And again, that's all for this applied project. Next video, I'll go over, I think, another applied project. So stay tuned for that. Anyways, hopefully you'll learn. Like always, you can download these exact notes in the link below. Thanks for watching, and stay tuned for another Math Easy solution.